What's up, team? Here we go, CYU number 2 for unit number 4, making a video in hopes that the paper copy and the video combined will help this make sense. I'm going to try to go through this quickly and efficiently while also trying to explain every single step that I'm going through here. Okay, so first, I'm noticing the rubric. It's a 4-point rubric, just like on the exam. To earn a 4, we need to solve the systems correctly, so we need to find the correct solution. Great. In addition to that, we need to put our answers in the form of coordinates, x, comma, y, just like we've been doing. The answers are verified, so that means that's when we go back through and we check it in both. Again, we've been doing that. Answers in part C is in a complete sentence. Notice it's words. We'll put it into words. We'll get there in a minute. And we show our work, or we show our process. I like that phrasing better. Okay. So number 1, I went ahead of time, red equation, blue equation. We're solving by substitution here. So that's the one where we're trying to identify either equation. We're trying to solve one of the equations for one of the variables. I'm noticing in this case, the red equation is already solved for y. So that step 0 is already done for us. So we know that y equals negative 5x. That means that this y here in the blue equation also equals negative 5x. So I'm going to rewrite the blue equation, negative 7x minus 6. But instead of writing a y here, I know that y equals negative 5x, and that's coming from the red equation. So I'm going to put that in red there. Now, here we have an equation that looks a little bit more complicated, but if you notice, there's only one variable at play now. So negative 7x plus 30x equals 23. Negative times a negative makes a positive here. Okay, now if we combine like terms, we see that 23x equals 23. Well, now, if we divide both sides by 23, let's do that here in blue, 23, 23, we quickly see that x equals 1. Great. So now we're going to go back through both the original red, original blue equations, plug in 1 for x, and we'll see what we can find for y. So in red, we have y equals negative 5 times 1. Well, that means y equals negative 5. Let's do the same thing for blue, and we'll wrap this thing up. Negative 7x, well, negative 7 times 1, negative 7 times 1, minus 6y equals 23. So negative 7 minus 6y equals 23. Well, if we add 7 to both sides, let's do that here, plus 7, we see that negative 6y equals 30. Now, when we divide both sides by negative 6, we learned 30 divided by negative 6 is negative 5. So then in this case as well, y equals negative 5. These two, they match. They're the same. That's important. That's a necessity. So our solution here is 1 comma negative 5 in parentheses. That's our solution. That's our finish line. Okay, part B. Red equation, blue equation, same sort of thing, really similar scenario actually. I'm noticing the red one is already solved for y. So we know that in this system, y has a value of 3x plus 4. So we're going to take our blue equation, just like we did a moment ago, and we have 6x plus 8. And 8 is going to be multiplied by the value of y. Y is 3x plus 4. 3x plus 4. And then we finish the blue equation. That was just the y portion. So we'll put equals 2. We're going to do some distribution here. 6x plus 24x plus 32 equals 2. I multiplied 8 by both terms here in red, both terms in parentheses. Let's combine some like terms, combine our x's. We'll see that 30x plus 32 equals 2. Now, we'll subtract the constant, subtract 32 from both sides. And then we'll see that 30x equals negative 30. Thus, x equals negative 1. Let's see, I'm going to kind of divide this up here. It's getting a little bit crammed, so double line. Boom. Okay. So x equals negative 1. That's our claim. Let's go back into red equation, blue equation, and see what happens when our x value is negative 1. So our red equation, y equals 3 times negative 1 plus 4. Y equals negative 3 plus 4. Well, that means that y equals 1. Cool. Let's play the same game with blue. 6 not x, because x is -1. So 6 times -1 plus 8y equals 2. -6 plus 8y equals 2. Let's add 6 to both sides. And then we see that 8y equals, not 6, 2 plus 6. 2 plus 6 is 8 today. If we divide both sides by 8, we see that y equals 1. And again, these match, which is great news. That's exactly what we need to find. So our solution here has an ordered pair. His coordinates, x comma y, is -1 comma +1. So -1 comma +1 is our solution. I'm going to make this one a little bit more aggressive as well. Those are the final solutions. Great. Let's play a game of some words here. During the basketball game this week, the concession sold a combined total of 84 sodas and hot dogs, meaning that if you count the number of sodas and you count the number of hot dogs, the total number would be 84. That's what's saying here. Okay. The total number of sodas sold was 5 times as many as the number of hot dogs. Okay, so the sodas, there was 5 times as many as the number of hot dogs. How many sodas and hot dogs were sold at the game? Great, let's create a system of equations here, then we'll go ahead and solve it. So I'm going to call this situation here combined total. This is going to be my red equation. So I'm going to use the letter S for sodas and the letter H for hot dogs. So I know that the number of sodas plus the number of hot dogs, I don't know how many sodas, I don't know how many hot dogs, not yet, that's what we're going to find out. But I know that the total number of them, if you were to add them together, is 84. So that's our first equation within our system. Let's find our second one here. I'm noticing that the total number of sodas was 5 times as many as the number of hot dogs. So the total number of sodas is 5 times as many as the hot dogs. Well, that's just 5 times the number of hot dogs. So if we know the number of hot dogs, we multiply that by 5, and that's how many sodas that were sold at the concession stand that night. Here we go. Here's our system. We're going to solve this one using substitution, because that's kind of the umbrella that we're under here for this question. Of course, you could graph this. You could do elimination, but we're not gonna. We're going to do substitution for this problem. I'm noticing the blue one is already solved for S. So if S equals 5H's in the blue one, then S equals 5H's in the red one as well. So let's copy down the red one. S plus H equals 84. And then I'm going to substitute this value of 5H in for S. And then I'm going to keep going with the red one, plus H equals 84. Now we're going to solve for H. So combine like terms here, and we see that 5H plus 1H is 6H equals 84. If we divide both sides by 6 now, divide by 6, we see that H equals, what is that? Is that 14? Because I know that 10 times 6 is 60, 4 times 6 is 24, 60 plus 24, I think that's 84, so 14. Now what this means is H equaling 14 in the context of this problem means that the concession stand, our claim, is they sold 14 hot dogs that night. So now let's go back, let's figure out how many sodas they sold. So we'll take this H equals 14, plug it into red, plug it into blue, and we should get the same thing, just like we did a minute ago. So in red, S plus H equals 84, but our claim is that H equals 14. So S plus 14 equals 84. Subtract 14 from both sides here, and we can then find that S equals 70. Let's play the same game with the blue equation and hope that we find that S equals 70. Blue equation is S equals 5H. So S equals 5 times 14. S equals 5 times 10 is 50. 5 times 4 is 20. 50 plus 20 is 70. Great, and these are the same. That's good news. So we're not quite done. We've done all the math, but remember, to earn a 4 on this question, it says answers in C must be answers C in complete sentence. Okay, so the student answers part C in complete sentence. So what this means, what we've learned, is that the concession stand that night sold 14 hot dogs and 70 sodas. So we can say something simple like they sold 14 hot dogs and 70 sodas. So here is our solution. And then of course, as an ordered pair, we can say something like 14, 70. I know it's kind of funny because normally the ordered pairs are in terms of x and y. We could say that h equals x and s equals y if we chose. Don't worry so much about the ordered pair in this case. That's more theoretical math. That's like what we do with x's and y's. When it's a more of an application type problem, the response we want to be in a complete sentence. Okay, my next video, I'm going to go over the next one.